Alright, ladies and gentlemen, in this video, I want us to focus on a goal of connecting some mathematical concepts. I want us to start thinking of how we can use what we know about tangents, what we know about central angles, about arcs, about inscribed angles, and start kind of connecting them to some other mathematical concepts. So let's take a look at the diagram that we have. We see this as the northern lights, or bright flashes of colored lights between 50 and 200 miles above the Earth. A flash occurs 150 miles above the Earth, so right here, 150 miles above the Earth, all right, at a point C. What is the measure of arc BD? What is the measure of arc BD? The portion of the Earth from which the flash is visible. Earth's radius is 4,000 miles. So here's our radius, okay? And since the radius is 4,000 miles, that's where it stops, and then 150 miles addition is another, obviously makes it 4,150. And so let's kind of think about this for a second, and what I really want you to do is I challenge you, stop the video, see if you can do it on your own before we continue. But what do we know? Well, we definitely know a handful of information, and I'm specifically going to focus on what we know about these tangents. The tangents, remember, are perpendicular to the circle's radius. The tangent is perpendicular to the circle's radius. If you haven't paused the video already, pause it now. I've scaffolded you a little bit, I've guided you along the way. See if you can now do it on your own. What did I create? I created two right triangles. And take a look at what I know. I know 4,000 and I know 4,150. Look at what I'm trying to find. The measure of arc BD. What angle is in relationship and equal to the arc BD? Well, that would be angle BAD. Angle BAD is going to end up being in relation to the arc. It's going to be the same thing for the central angle. So how does this benefit us? Again, if you haven't paused the video yet, try now. Now try to pause the video and finish off the problem. Let's continue. Well, what do I know about these two triangles? Well, these two triangles are going to be congruent triangles here. So, and I know that in this case here, we have hypotenuse-leg theorem. Hypotenuse is congruent, and a leg is congruent on both sides. All right, so hypotenuse-leg theorem says these two triangles are congruent. So that means that the relationship between arc BD is between that and our angle BAD. But since the triangles are congruent, it gets bisected right there. So if I focus in on the measure of angle CAD, for instance, if I focus on the measure CAD, right here, CAD, what do I know? Well, if this is the angle I want to know, I have its adjacent side and the hypotenuse, then that means that the measure that I'm looking for is going to be the measure of angle CAD will equal the cosine inverse of adjacent over the hypotenuse. Think about what happens here. That's our right triangle trig functions being utilized all together. So now, once we find CAD, then it's just simple multiplication by 2 because it's going to be by. Alright, so when we go ahead and when we find our angle CAD, alright, this is roughly going to be about 15.5 degrees. And again, all we did there was we took 4,000 divided by 4,150, hit second cosine in our calculator, or if we're using a graphing calculator, you can just do second cosine and put 4,000 over 4,150 all in one. That means that the measure of angle BAD is going to be 15.5 times 2, or roughly about 31 degrees. Love that problem. I hope you challenge yourself and kind of went along with it and paused the video when I told you to. It's a great kind of conceptual type problem connecting a lot of pieces of geometry.